What's up, my coders? If you've been following this tutorial so far, you probably feel like a real coder, and you are. But listen, with the skills we've learned so far, your code probably takes off and runs to the end like Leroy Jenkins. However, with the nuts and bolts we're going to cover today, our code is going to start to get a little more intelligent. But be warned, with intelligence comes complexity. Let's dive in. Hey, welcome back to the tutorial. If you're here, you're coding with Paris, and in today's nuts and bolts, we're going to cover something that's going to take our code to the next level, and that is branches and logic flow. This is one video of a series I'm putting together called Coding Nuts and Bolts. And folks, basically what it's doing is just teaching you how to learn code as quickly as possible by focusing on the 20% of concepts that are going to teach you about 80% of what you need to know to start diving into your own coding projects. So before I dive into the content, I want to ask you to like the video, subscribe to the channel, hit the notification button, and go ahead and share this video. And if you have any questions about the stuff that we've covered so far, put it down in the comments below. I'll try to answer you if I can, when I can. Anyway, let's get to the content. With the first leg of logic flow, which are functions, under our belt, and now just completing our side quests and learning about expressions and comparisons and all the little bitty operators that fall underneath, we now have all the nuts and bolts we need to start to learn that second leg of logic flow, which are branches. Before we dive in, we need to understand that we're starting to get into the nitty-gritty of what makes your code intelligent. And with intelligence comes complexity. So pay close attention and make sure that you follow along with the examples in order to lock this stuff down. Okay, so now what I need you to do is to go over to your lesson 4 folder. We're going to expand it here just for visibility, but I want you to create a new file and we'll call it branches.js. Hit enter. Let's talk about what the heck branches are. Branches, the second leg of logic flow, are another thing you will commonly see in computer programs. And what they are is a way for basically our code to start becoming a little bit more complex. It allows our code to make decisions on what piece of code to run based on the condition of which we're checking, right? And usually that's done by Boolean, by comparison and comparing things or checking the value of things, which we basically covered in expressions before. The easy way to think about branching is it's a place where the code can decide to do one thing or the other. And the reason why it's called branching is because there's actually a split. Okay, there's a split in execution. Each way that things can run represents a different branch in our code in execution, and that's why we call them branches. When the decision is made to travel down one path, the other paths of the code are not executed in that case. But just remember, all paths of the code should be considered when you're writing code, okay? Do not be sloppy and only pretend that one branch is going to be ran when you actually create something called a branch. And we're going to talk about examples of how to do that, but always remember, check and account for all branches of code when you write it. Why would anyone use branching? Once again, branching is used to make your code more intelligent, right? You actually have code now that can start making decisions, and we start getting into things that start to look a little bit more like artificial intelligence. Let's say you're writing code to calculate the quotient of two numbers, but you don't want to do so if you're dividing by 0. Well, now your code is smarter. It sees that one of the numbers is zeros. It could do something different. It could just not run. That's an example of a branch. Most languages provide 2 ways of branching code. The first we're going to talk about are if-else branches, okay? Let's look at an example of how if statements work here. Let's say we have a value, let x equal 1, okay? And then let's write the statement if x is greater than 0, console.log, greater than 0. Let's run this code and see what happens. So we're going to come down here. Let's go ahead and type clear to clear out our console. But we're actually going to tell Node to run branches.js instead of expressions.js. Okay, and you'll see that greater than 0 is printed right here. Why is that? Well, because we gave it a condition and we're saying if whatever in here, this condition actually converts to true, right? So the condition in parentheses converts to true value, run the code in between, right? So run the code in between. So basically the way if statements work is if the condition, if the expression given returns true in any way, this code is going to be ran, all right? So let's go ahead and switch that up just to nail things home here, okay? So we're gonna take this actually, and we're gonna say, let's just say it's greater than 2, right? And go ahead and run this just to show you. And you'll see that nothing happens, right? Nothing happens because x is not greater than 2, right? Nothing. Okay. So now we know that if statements, the way they work is the condition here should be set to true. Let's talk about logic flow here. Well, we have this condition that's met. So if we're talking about the way logic is ran, we have let x equal to 1 being actually ran first, and then the code actually goes to this next line and says, hey, is x greater than 2? If not, it's going to skip it, right? It's going to jump around and it's going to say it's done. Whereas in this first example here, it checked to see if x is greater than 0. And because that condition was met, then this was actually ran, and then the code moved on. So we have two representations of what's going on here. There's a condition of which this is actually being ran, and then there's a condition of which it's actually being skipped. And that's called a branch in the code, okay? If we were to depict what a branch looks like in logic flow, it would look like this. In the first path, this is the condition of when that x is actually being ran, and this represents the condition of when that x is not being ran. Let's expand on this a little bit more, okay? Let's make our code even smarter by introducing the else, okay? So let's say we let x equals 0, and go ahead and comment that out real quick, okay? And then come down here and say, let's introduce the else, okay? So now we can come down here and say, if x greater than 0, I want you to run console.log x is greater than 0, but then in the condition that this is not being met, I want you to do something else, okay? I can say it is not greater than 0, probably 0. What's going to happen when we run this code? Let's go ahead and come down here, press yep, and you'll see that because x is not greater than 0, then this condition is met. Okay, so logic flow is we set this variable, and then we check here. This is where the branching occurs. It says, is x greater than 0? Right, the first branch. You'll see that that is a no. Okay, the second arm of that branch here, this else statement is saying, hey, if this condition is not met, go ahead and run this code here. So a couple of things to know about the else is that the else cannot exist on its own. The else can only exist as a part of an if statement. The second thing to know about the else is that the else is ran because the if isn't true. So you usually see these in pairs, and that's usually like when you want to do some execution in case something is not found in the code. Now we could certainly have just taken out this else and ran this without the else condition, but then that wouldn't really tie these things together. So do this or do that is kind of what you're trying to do with this else. So you're kind of tying these two pieces of code together. And this is what it looks like as an illustration. Again, here you do have a branch, and you're saying, if this condition is met, run this line of code. If it is not met, then definitely run this line of code and then return to execution. So execution is still from top to bottom, but here's the two different branches or two different paths that things can travel. Now, one other thing I'm going to do is, so we can say branches are here, but one other thing I'm going to do here is I'm going to type after something after, and I'm going to run that for you. You'll see that something after happens here. If I were to change this to 1, you'll see that it runs x is greater than 0, right? This condition, and then something after. See, something after runs no matter what. It doesn't matter if this or this condition is met. It runs because the way the flow works is it runs this line, checks this variable, and if it's true, it jumps into here. If this condition is not true, then it always does what's next here, and then finally it moves on in execution to the next line. Okay, so wrapping things up with our branches here, we use if-else branches when we want two conditions to be tied to each other. This to be ran, this to be done whenever a particular condition is being checked. And then we can put the rest of our code outside of that if we want that to be running regardless of what happens here. Okay, so this is making our code smarter. So that's if statements. That's one level of branching. Let's talk about another level of branching that you might commonly see in code, okay? And that is something called case statements. Case statements. So a lot of languages have the if statements for branching, but in some cases, you might have something a little bit deeper, a decision tree that's a little bit more complex than do this or do that, right? And that's where something like case statements can be used. Case statements are basically if statements, except they allow you to have unlimited branching. They allow you to have many cases that you might want to evaluate for true or false, and they're usually done in absence of an if. Now, case statements are implemented in a lot of coding languages, and a lot of folks do this instead of several if statements. They just do one case statement. Let's give an example of case statements and then talk about where you might want to use them. So let's set a variable, let return day of week name equals function day number. And what we're going to do in here is we're going to write our first case statement. So this is the way it looks in JavaScript, and this syntax may change depending on your language, but it looks very similar at the same time in between languages. Okay, so in JavaScript, the way we do is we say, hey, case day number. Okay, so we use the word switch, and then we put in parentheses the expression that needs to be evaluated, or the usually it's something like a value that needs to be evaluated. Okay, and what we're going to do here is we're going to start giving our cases. We're going to say if case, let's say in the case that number given is equal to the number 1, then what we want you to do is return the value Sunday. That's the first day of the week. Let's say it equals 2. Let's return the value Monday. Let's say it equals the case 3. We'll return the value Tuesday. And let's go ahead and do the others as well. And we don't even have to finish that. We kind of know what's going on. And actually let's do a default, right? So if it isn't equal to the numbers 1 through 4, let's just say we want it to actually return So now what we're going to do is we're going to run this function. Let's go ahead down here and go console.log, and then we're going to say return day of week, and then we'll pass the number 5. What do you guys think is going to happen here? Let's go ahead and run it and see. Let's go down to our console, maybe clear it up, and run branches. Oh, it's going to tell us to pick the numbers 1 through 4. Now, what's happening here in this case statement? So we have the setup of a case statement, which is switch. Okay, again, we have the number that's being evaluated. And when we run this function, and we're saying, hey, in the case that the number is 1, do this. In case that the number is 2, do this. In case the number is 3, do this. In case the number 4 is do this. And if in any of those cases aren't returned for any way, then we want it to fall into this block of code, which is just called default, and we can we can tell it to do this. Okay. Now, my rule of thumb about case statements is that I would usually always set them up with a default value. And the reason why I would do that is that forces you to think about what might happen if what your cases aren't being met, and it helps you think about what type of execution or what you might want to happen for that case. Okay, so rule of thumb is always add a default and some expected behavior that you want to happen if things fall outside of your cases. Okay, something interesting about case statements that I failed to show you here. With these case statements here, as I have this wrapped in a function, these are basically returning a value. So ending execution of the function here. There's something else you might see in case statements that you probably should know about. So what I'm going to do is I'm going to take this case statement and I'm going to create kind of an alternate version of this. Okay. So I'm going to comment this out. I'm going to create an alternate version of this. All right. And what I'm going to do is I'm going to create a variable called let value to examine. Okay. And I'm going to just make that a 1. Okay. We'll change this to value to examine. One thing you might see in case statements is that if you're not doing something like returning something in a function here, you might see these return functions not being here. You might see break. In between all of your cases. And what this break is doing is this is just letting the code know, hey, we're done with the execution here. We're going to break from this branch and we're going to jump outside the cases and continue execution. Let's just see what happens. How about that? Okay. Oh, by the way, I have to, maybe I should do console.log in front of all of these. I'm ad-libbing a little bit here. Okay, console.log. And I'm just pasting console.log in front of all of these. One more. Okay, so we'll run this. And you'll see that Sunday is printed. Why is Sunday printed? Because the value to examine is 1. Okay, so if we make the value into examine 3 and we run this again, you'll see it's Tuesday, right? And let's say the value to examine is 6. What do you think will happen? If you guess, it will say pick a number 1 through 4. Now what happens if you don't put this break in here? Well, actually it gets pretty wonky, okay? So always put the break in there. This branching gets interesting. Let's go ahead and do an illustration of what the branching is doing here, okay? So this branching actually goes ahead and sets up several tracks here, 1 for each version plus the default value if none of the conditions are met. It runs that branch of code and then it continues on in execution. And again, you want to account for each branch when you are writing your code. This is the way that you make your code super complex. This is the way that you would start to do something that might look a little closer to artificial intelligence. Use case statements in the case that you don't want to do an if then that. If you want to check for several conditions, maybe above 3 conditions, you should be good. And yeah, you could definitely replace a switch or a case statement with a bunch of ifs. You can definitely do that, but again, it becomes a little sloppy. It's nice to organize. You put your cases together like this, then someone knows what you're attempting to do really quickly by looking at your cases. Kind of like what you see here with the example of the day of the week being returned based on the numbers. So let's go ahead and comment this out and talk about one final thing with branches. It's actually going to be an expansion of the if then else statements. So I kind of lied to you before. The reason why I did is for simplicity. Now that we've covered case statements, I'm going to expand on our if-else knowledge and actually talk about one more kind of exception or add-on to that if-else statement, okay? And that is else if. And some languages have this concept, some don't. A lot of the newer ones do. Let's say a language doesn't have a way to set up case statements. What you can do is you can actually use an expansion to if-else, which is kind of an else-if, to add more and more cases. I'm going to give you one example of that, okay? So what I could do is I can say let else if number 0, and then I say if else if number is equal to 0, then I want some condition to happen. Console.log I'm equal to 0. Any of you smart people might have been able to catch me here, okay? So yep, I didn't use the triple equal, sue me. Let's move on, all right? Okay, so now we're gonna actually add something called an else if to this. And what that basically looks like is it looks like this. I use the term else if here. Else if number is, let's say greater than 0. I want this branch to do something else. Console.log I'm greater than 0. And then we're going to end this with an else because we know what that is. We're going to say console.log. We're going to say if something doesn't meet the condition of being equal to 0 or greater than 0, then we're going to say I'm probably less than 0. Ooh, that's funky. Okay, so we set this number to 0. What do you think is going to happen if I were to run this? So I'm going to press the up arrow key and run it, and it's basically going to say I'm equal to 0. Okay, so what's happening here is that this first condition is met. This else if allows us to introduce another branch, okay, another expression to be made. So I can do that here. Let's go ahead and do that. Let's just make this a 1. Oops. A 1. Hit save. Come down here. And here you go. You see it runs that condition. I am greater than 0. Okay. Let's say it's 10. And then come down here and run our code. You'll see that it says I'm greater than 0. Because it didn't follow this else. Why is that? Well, that's because this else if condition was met first. In fact, the way I set this up is, gonna probably fall in here. Let's say that it's equal to -1. Ooh, okay, right. So if I do that, come down here, run this code, you'll see that now what's printed here is that I'm probably less than 0. We know that -1 is less than 0. Okay, so either way, the else if cannot exist without the if, but the else if allows us to add another condition to this code, okay? So now I can go if this or if this, right? Else do this. So do this or do this, then do that. Sounds like a rap song. We can add as many else if conditions that we want. So now let's say I actually came down here. I have to go outside of the else, and let's do another else if. Let's say else if number is equal to 5. We want to do something with, okay? So yes, I am equal to 5. That's special. All right, let's come down here. Well, let's change this to 5 first, right? And actually, when I'm doing this might actually fall into here being greater than 0 first. So let's take that else if statement out and put it before this one, huh? Let's put it right here just to get real fancy, right? Real fancy. All right, here we go. I'm saving it. I'm gonna go ahead and run that code, and it's gonna say, yes, I'm equal to 5. I'm gonna run this here. And then it runs this code, and then it doesn't do anything else, right? It doesn't run any of these other conditions because it met this one first. So wrapping it all up, else if statements allow us to add several conditions that need to be met, but only one of these can be met. Okay, I would probably use this in case if there's an absence of case statements in the computer language that you're using, but it's okay if you do use it as well. I go back and forth a lot on this one. I like case statements because they're easier to read, but that's just a personal thing here. And that's the end of what we call branches. We've talked about expressions. We've talked about branches, which is another arm of logic flow. Let's put all of that stuff together by working on another huge example that ties everything together, okay? Let's do that right now. So we're going to go over to our lesson 4 folder again, make sure it's expanded so you can see everything that's in there. We're going to actually create a file that's called guessyoursign.js, okay? I'm going to give you the requirements for this, okay? What we're going to do is write some code that's going to ask for your birthday month. And the code is going to ask you for your birthday month and then wait for a response, okay? And it's going to allow person to enter their birthday month, right? Numbers 1 through 12, right? is going to use if statements to handle blanks or numbers not in 1 through 12, and it's going to use case statements to return your sign on month given. Okay, and then it's going to print that response for the person. Okay, so before we dive into this code, I just want to let you know that there are particular pieces of this example that involves some nuts and bolts that we have not covered yet. We'll probably cover those in a later tutorial, but we want to use a piece of this functionality to kind of make our example really cool. So I'm going to write out some code that I want you just to blindly copy. I'll let you know what those are. Maybe I'll even put a comment above them, just kind of explaining what they're doing. But just go ahead and glom on to the things that you already know and the things we're trying to solidify here. Feel free to do some research on what they are and what they're doing a little bit later, and to play around with them in your own time if you like. So on our program here, what we're going to do is we're going to set up a couple of variables that we're going to use throughout our program. Okay. This first one is going to set up the input reader. Okay. So the input reader is just a piece of code that we're going to use to actually prompt with a question and wait for an answer. Okay, so just copy this. Reader maker equals require node read line. Okay, the next variable I want you to do is let reader, and this one is going to be reader of the response from user. And then the next one is going to be hold the answer for further processing in code. Okay, so let answer, we'll just call that variable answer. So now we have our three main variables that we're going to use throughout our code. Okay. So if you ran code with me, or if you've written code with me before, you would remember that there is a certain pattern that we use to kind of generate code, okay? And that is, we have a main function that we create, and we have that function kind of orchestrate all of the things that we might need to do in our requirements here. Let's just call these requirements, okay? And we have a main function that we use to kind of do everything we need here, okay? So we'll call that function, we'll set up that function here, function run. Now, you may have quickly noticed, because I know you're smart cookies, that I did something a little bit different here. You'll see I just used the function keyword and then add run and open paren and close paren. This is kind of the new way that functions are created in JavaScript. If you're dealing with some legacy JavaScript, you might see the old way and the new way. So this is the way you can do it the new way. It's a little bit quicker. So anyway, in this function, when I write these functions that orchestrate things, I usually like to leave notes in here to kind of remind me what I'm doing. So the first thing we're going to do according to our requirements is we're going to prompt user for birthday month, right? The second thing we're going to do is check the answer for valid answers, right? So we want the month 1 through 12 and no blanks, okay? And then how we're going to do this is use if statements to handle these cases, okay? And then we're going to finally go back to use case statements to return the sign based on the month number. So actually, before we do this, I'm going to ask you to copy me blindly, have faith in the coolness of this, and then we'll circle back and kind of talk about what's going on here. So before we ask for the user for the month, what we're going to do is we're going to set up the reader, okay? And basically, I'm going to create a function called create input interface. We're going to come above that function here, create an input interface. We're going to do some magic in between. So that magic is basically, we're going to say the reader is going to be equal to reader maker dot create interface, and then between it we're just going to do this. Okay, just copy me, don't worry about it, do as I say, and it will be awesome. Okay, all right, so this piece of code is setting up our code that's going to actually get ready to take an input from the user, right, to prompt the user. And then what we're going to do after that is we're going to write some code now that's going to prompt the user. Okay, so we'll call this take input. Okay, and then we'll go above here again and we'll create a function called take input, right? And don't forget to put the word function in front of it. And what this is going to do is tell the reader to ask the question, please enter your month. And we'll just give it an example here, IE 1 through 12, and we'll take the input from the response, just copy me, and we'll say answer equals the input because the answer is a variable we created before, and we'll tell this reader dot close. Okay, then we'll just come down, we'll clear our console, and we are still in the lesson 4 folder, so we'll say node run guess your sign.js, hit enter. Actually notice that nothing is happening. That's because we didn't tell the code to run our function. So let's go ahead and say run. Okay, kind of below everything, let's add the text run, and let's go back up here and say node. And now you'll see here in our command line is actually asking you a question. It's actually asking you to enter something. You'll see a colon, and then you'll see a cursor here waiting for some kind of response. Let's go ahead and enter blah, 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 garblegook, hit enter, and you'll see that now it's kind of back to normal. The program actually finished execution and didn't do anything with it. So all of that was just to kind of set up our reader to ask a question. Okay, now that fulfilled the first part of our requirements. Let's make our program smarter and have it actually respond to your answers. Okay, the next piece of our requirements is to write some code that inspects the answer and makes sure that it's the numbers 1 through 12 or that there's no blanks, right? So there's kind of a validation step. So let's write that function out. Function is valid. Okay, so our code is pretty much asking, is the answer valid? So we're going to return true or false. We're going to return false if the answer is invalid, and we're going to return true if the answer is valid. Okay, so how will we do this? Here's a common pattern you might see. First thing you might see is someone might set a variable, and we'll say answer equals, I'm a negative Nancy, I'm going to default it to, let's just say I'm positive Paris, and I'm just going to default the answer to true. Okay, and what I'm going to do here is I'm going to return true. Okay, what happens here? Well, return valid answer. All right, so we created just kind of the shells of our question here, and let's just go ahead and add it here. Is answer valid? And then run our code. Now you'll see that it's asking again what the question is. If I hit some gobbledygook and then hit enter, code really isn't doing anything with that. Now this is actually being ran, right? This code is actually being ran because it's being called here, but nothing's being done with that answer. So let's do something with this answer. All right, we know that we have some things that we want to do if the answer is true or false, right? So let's go ahead and use our if statements and say if answer is valid, this is now an expression, then what we want to happen, if this is true, then we want to console.log, something, your answer is valid. Okay. If it's false, right? Console.log, your answer is invalid. Okay. So let's go ahead and run that piece of code just to see what happens. Okay. So now immediately it's kind of returning, now that I hit enter, immediately it's just kind of printing out your answer is invalid. Well, basically what's happening here, if we were to look at the way things are running, okay, what's happening here? Well, what's happening here is if you scroll to the top here, everything is being set up, right? And then we go to this run function. This run function immediately runs the create interface function first. So let's scroll back up to create interface function, and it's setting up our reader. Okay, so it's doing some black magic there. Immediately once it does that, then what it does is it runs this function called take input, right? So it's writing this, it's trying to take our input, but immediately what it's doing next is it's actually checking to see if the answer is invalid or not. So it's not even really waiting for an answer, it's just kind of doing what it wants to do there. Why is this happening? Well, basically what you need to know is that we want to do this sort of thing here after the person gives us an answer. And the way we do that is we go back up to the take input function, and inside of this open and close bracket here is where we put the code that's going to be running after the reader takes the answer. Okay, so you might be saying, Paris, why in the heck do we care about that? Listen, for the sake of this example, let's not dig too deep into that right now. Let's just take that code that we just wrote, that if-else statement, and put it in here. Save it, and then come back down, clear our console, clear, right? And then what we're going to do is run our code again. So now you'll see it actually waits for an answer. We'll put some gobbledygook, hit enter, and it says your answer is valid. Oh, why is it saying that your answer is valid? Well, that's because actually, if we go to our function here, where we're checking to see if the answer is valid or not, we told it just to return true, no matter what. But we know that this gobbledygook is not valid, and so let's make our code even smarter with our if statements. All right. First if, okay? So if answer, and this is referring to the answer variable we created at the top, if answer equals quote, quote, with nothing in between, hey, that actually is considered an empty answer. Then what we're doing here is we're going to set valid answer equal false. Okay, so before we move on to other cases, let's go ahead and run our code. Let's go back down, and it's going to wait for an answer. Now, instead of entering gobbledygook, let's enter nothing. What happens? You see that our code now says that the answer is invalid. Okay, so we've prepared for the first condition if the answer is blank. Now let's prepare for another condition. Let's use our else if answer. Let's say if the answer is greater than 12, which we know is an invalid case. Okay, then we can say valid answer is equal to false. Why is that? Well, the number cannot be greater than 12. So now we can come in here, let's save our answer, run our code, okay? Let's say we gave a number that is greater than 12, 13. Our answer is invalid, okay? Now, let's check for one more bad condition, right? One more bad condition, which is else if our answer is less than 1. Then we know the valid answer is equal to false. Notice I'm using the single equals because we're setting, okay? And all three of these. So these are the 3 conditions in which we were told in our requirements to check. Okay, so let's save. Let's come back down here in our code. We're going to run this. It's going to ask us for a response. And let's just say we had like a -1. Okay, your answer is invalid. All right, so now if we run this code here and we do anything else, if we do anything between 1 or 12 or not blank, right? Let's say 3, then we know our answer is valid. Okay. Now, I'm going to go back and give an invalid answer just to prove a point here. Let's say we did -1 again. Okay. Your answer is invalid. Now, when you're writing code, this sort of answer is not very descriptive. So let's go back and make this right here a little more descriptive to kind of help the folks using our program know exactly how to correct their wrongdoings. So instead of your answer is invalid, this is what we want. We want to actually say something like, you entered an incorrect month or a blank answer. Please try to enter a month 1 through 12. Okay, so this gives the user an answer to what might be driving their problem. So if I go down here, enter -1 again, now you see a little more of a helpful error message. Okay, so we've completed step 2. Now let's go back to our run function. Scroll down. I hope I'm not making you dizzy here. This next thing that we need to do is we need to actually return a person's sign based on their response, their month number. Okay, so this is what we do. We actually create a function called guess the sign, and then maybe even, maybe we'll throw answer in as input here. Okay, this is kind of strange since we already know the answer is, but let's just say we were to take that as an input. So what you do here is create a function by this name. Maybe just go ahead and do it right up top here. Function guess your sign, and we'll take an answer. Okay, and we'll do this using case statements, right? So we'll do this using case statements. Let's go in here and we'll say the following. Actually, what I'm going to do is I'm going to copy my case statement, and I'm going to give you the access to this case statement somewhere so you don't have to write this longhand, because it can be pretty lengthy. But essentially, this is what's happening here, okay? This is going to take your answer, and it's going to say, if that answer is number 1, then I want you to give the following answer. You're an Aquarius if your birthday is before the 20th. Otherwise, you are a Capricorn. So that is if the answer is 1, meaning January. And this is February, March, April, May, June, so on and so on. So anyway, I'll give you a place where you can just copy this and paste this inside this function instead of writing it longhand. But you will scroll through, you'll see 9, 10, 11, and 12 months. And after each case statement, you'll see a break, meaning that we're done with the execution. We can jump outside of this case statement, okay? Now, this function, guess the sign, again, was added to this run method. Let's go ahead and run this code and see what happens, okay? So we'll hit enter. Let's enter a number 1 for January. Hit enter. It says your answer is valid, but it's not really doing anything, right? It's not really doing anything. Why not, right? What's going on here? Well, what's happening here is that when this run function is running, it's running to create the interface again. It's taking the input. It's trying to run guess your sign with the answer, but guess what's happening here? It's trying to take off with the answer at this point without waiting for the response. So you get nothing. You get nothing here. So in fact, I should do a default in here. Let's add a default in here to just make a point. So default, and we'll just say console.log, guess the program ran away again. And what we'll do is we'll go ahead and clear this and run this, and you'll see right here, it's kind of just doing stuff. It's not really waiting for a response. It's just kind of acting weird. And the reason is we don't want to guess the sign until we have the answer from the user. So we're going to take our guess the answer out of here in the run function. And what we're going to do is we're going to look for the part of the code that waits for the response from the user, which is everything inside of these two curly braces, right? So you'll see here that we check for the answers right here, and then we do certain things based on if the answer is correct. If the answer is incorrect, you'll know that this piece of code is ran, right? Now, folks, what we're going to do is we're going to replace this "your answer is valid" piece with our function, okay? And what this is going to do is this is going to take your answer and run with it now, just based on what the input might be from up there, okay? So now, let's go back here. We'll save our code, run, okay? And you'll see now, even with the default, it's not doing anything. It's going to wait for our answer. Press enter, and you'll see that it's now saying you're an Aquarius if your birthday is before the 20th, or in Capricorn. Let's add another month in there, okay? Let's clear, and let's do a 6. Ooh, you're Gemini if your birthday is before the 22nd. Okay, let's do one more just for fun, right? Okay, so we're going to run this, and we're going to look for an answer. Let's do an answer of 9. What happens? You're a Virgo if your birthday is before the 23rd. Otherwise, you're a Libra. Ladies and gentlemen, we have fulfilled our requirements. We're printing a response. We have some code that's smart now and actually knows how to respond to answers from the user. If you've done this, you probably feel super awesome, and give yourself a pat on the back, because you are writing some complex code that now knows how to decide based on the branching criteria. Now, what some of you might have noticed, and if not, don't worry, I'm going to share it with you. If we go back and run our program, you'll see that there was a condition that we did not check for. And let's go ahead, and you'll see that we went ahead and we checked to see if there was blanks, right? We went ahead to check to see if a number was in between 1 and 12. So if I do a 13, you'll see that, hey, this isn't right. But what we didn't check for is if someone entered that gobbledygook again. Program just kind of runs away. It doesn't know what to do in that case. So we kind of built in a bug, right? And that bug is just saying, hey, we still kind of have this condition of where something is not fitting right. And basically, it shouldn't have gotten this far. So what we want to do is we want to make sure that someone's actually entering a number or something that looks like a number. We don't want gobbledygook. So I'm just going to stop this here and just give you a bonus point if you can figure out how to check to make sure that your case is a number. So let's go back up to our conditions, okay? So we're going to say a bug is left in the program, bonus for checking if answer is a number or not, and failing validation if not, okay? But I'm going to leave that for you to solve on your own time, give you a little bit of a challenge. If you follow me this far, this was a long one, but I hope that you feel that it's worth it. You are definitely a coder after following this one. Great job, guys. So let's recap things, okay? So the first thing we covered here was something called expressions. And the reason why we covered expressions is because expressions can be used in helping make your code a little more intelligent. Expressions can be used in something called branching. Branching is a concept of taking our normal logic flow and giving it actually more paths to travel. And usually the branching happens by evaluating an expression and then deciding what to do next. So what makes our code more intelligent? That is actually making a code check for condition of something that's going on and deciding what to do based on what that condition is happening. So you take that expression, you check the condition of what's going on in the code, and then you run pieces of code accordingly. So then we dove a little bit deeper on the branches of code and different ways you might be able to branch in code, or you might see others branch in code, which is using if-else statements, else-if statements, and case statements. Each one of these kind of have their specialties, but they allow you to do different things based on different conditions. making your code seem a little more intelligent. We then tied everything together in our code by combining both examples of branching and a final program where we actually wrote some code to ask the user for input, which is their birth month, and then gave them an answer of what their sign is based on what they gave as an answer. So we covered a lot of ground in this tutorial. It might have gotten really long in the tooth. I'll try not to make a tutorial as long as this one, but if you stay through to the end, you are a warrior, and this definitely is a good set of nut and bolts to keep in your pocket. Take this stuff with you, keep this program and this code to come back to and study, and don't forget, go back and do the bonus if you are a killer. Anyway, thanks guys. I'll catch you in the next tutorial. We'll go a little bit further in the nuts and bolts. Peace.